any questions, left over from the first half of the class? Okay, no questions. So can you, let's see, Amia, did you say it was Amia? Do you have your hand up for a question or?
Oh, no, I was just raising my hand to say I was back, sorry.
Okay, great, thank you. Okay, so can you all see kind of a big blank white document? Okay, great. So this is the whiteboard environment that I will typically be using when I'm lecturing. And so there's two whiteboards possible on Blackboard. One is this one, which I just share. And I use this because it's convenient for me to write on, to change colors, to erase, and things like that, and then to save all of the slides for you later. But there's also a built-in Blackboard option for a whiteboard, which will allow you to write on it. So we're going to be making use of that second one in a little while. But for now, I wanted to just start by, why is this doing that? Having some technical difficulties with it today. But I want to talk about physics and just what physics is. And I really don't know why it keeps doing that weird thing. Let me see if I can get this working a little bit better. I know what it is. I have touch screen on and my hand is touching it and it's freaking out. Okay, so I want to talk about, why can't I turn off touch screen? It's not always going to have this many difficulties, but this morning I had a little trouble with my screen. So let's talk about physics, and I'd like to start with maybe brainstorming a little bit, and you guys tell me, someone in this class, tell me what you think physics is.
I like the law of motion.
Okay, who said that? Zoe?
Yeah.
Okay, law of motion. So, okay, anyone want to add anything to that?
I always just go to different types of energy.
Say that again.
My mind goes to different types of energy.
Okay. All right, does anyone want to add anything else? What do you think physics is about?
Motion.
Okay, so we have one person who said motion, law of motion. Do you mean something different than laws of motion?
No.
Nature.
Okay, nature. What do you mean by nature? Who said nature?
I mean the nature around us, like trees and everything like that, and water.
Okay, so kind of like Mother Nature. So that's a really interesting thing because the word physics itself, it comes from a Greek word, physis, which literally means nature, but it's more like the nature of things than like natural, well, how we use the word nature, like Mother Nature, plants, animals, those type of things. And historically, physics was really the study of the nature of things. And that could be plants and animals, it could be rocks, it could be you know, the heavens, it could be people, it could be basically everything that we would today call science, was sort of fell under physics originally. But now it's kind of come to a little bit more refined meaning. Would anyone else like to add anything else that you think we should add to defining physics?
Mathematical science.
Okay, I really like that mathematical part. Obviously, other sciences are also mathematical, although not all. So, but typically, virtually every science today tries to incorporate as much math as possible, because math is a sort of a universal. It's a measurable thing. It's something we can, if we have numbers on something, we can compare numbers and see if we're in agreement. And it's a little bit harder to do that with things like beauty or, you know, I don't know, feelings. Those are things that are a little bit harder to compare because they're hard to make mathematical. So for sure, physics is probably the most mathematical of the sciences. We really try to ground everything in mathematics. And even though people in chemistry and biology also use mathematics, it is a little more fundamental in physics. Good. So, so far, we have largely a list of things. Come again?
Matter.
Matter, okay. So we have matter, we have energy, we have motion, the nature of things using math. And largely what we have is a catalog of the types of stuff that's discussed in a physics class, but we haven't really distilled what exactly physics is yet. And that's what I really want to talk about. And the thing about it is that physics is kind of a hard thing to define. And in fact, everything is hard to define if you come down to it. But I'm not really good at defining everything. But I'm going to try to help us work on a definition of physics. And I'm going to do that with this little demonstration object. Okay, so I have here an object. And what is it? It is, it's a tube, and it has a rope coming out of it in 4 different places. So raise your hand if you can see this. I'm not sure if it's showing up well. Okay, great. So now let's watch this and try to understand what it's doing, because this object is going to be our metaphor for physics, and it's more fun to use this object in class. But you can see what happens when I pull the rope from one side, it comes out of the other side. Okay, or it doesn't even have to be the other side. If I just pull one rope, the other rope goes in. And raise your hand if you're kind of getting the gist of how this thing, you know, what it's doing. Okay, good. So now, raise your hand. Okay, stop raising your hand about getting the gist, because I have another question. Raise your hand if it's a little confusing. It should be a little confusing. Like, what the heck is going on? How does this thing work? So the idea here, and we're going to do a little exercise. The idea is that we have an object. We are observing something. We have some phenomenon that we're out in nature and we see something. And we want to know how it works. What's underneath it? What's inside? Because for me, if I look at it, if I just see this, I kind of assume that this is one piece of rope right here. This is one piece of rope. And I think it makes perfect sense that when I pull the rope, the other side of the rope comes in. But as soon as I do that, I go, how's that exactly working? My first assumption was wrong. It can't be that we just have a piece of rope that's just going, through her, because it doesn't really matter which rope I pull on. The rope that's sort of sticking out is going to pull in. So in physics, we see this kind of thing all the time. We have some observation that we make, and we have this curiosity. What's going on inside? What is causing this? What's the mechanism? How does it work? And so what we do in physics is we try to make a model. We try to make a guess, a model for how it works. And then we communicate that model with other people. And while we're making models, other people are making models. And so what we're going to do right now is I'm going to split you up into rooms. We're going to go to breakout rooms, and I'm going to go ahead and show you, if you, the bottom right, there's kind of a little toolbar and menus, and there's one that allows you to share a blank whiteboard. So this is the built-in Blackboard whiteboard. And there's a pencil tool, and we can draw, let me clear that and try again. So we can try to draw a picture of this where we have a knot and a knot and a knot, and then one of these guys is pulled out longer so that the knot is not touching the cylinder. And maybe we want to draw this looking more cylindrical. But at any rate, what do I mean by a model? What I mean by a model is drawing what's inside. What is going on inside? And so what I'm going to do is split you up into smaller rooms of maybe 4 or 5 people, and each group is going to create your own whiteboard, talk to each other, and try to come up with a model, or more than one model, as many models as you can think of, to explain how this works. And then we will meet back in 5 or 10 minutes. I'll kind of go through the rooms and make sure everybody has an idea what we're doing. And after each group has come up with a model, we're going to discuss those models together. Okay? So any questions while we're all in the same room, what we're going to be doing? Okay, so let's